So here we are talking about section 6.2, integration with substitution. You're going to need to know these integral shortcuts to be able to do all this stuff. You actually already know the one in green, and you know some of the ones in orange. All of these are going to be flashcards. So I'll give you a second to go ahead and write these down and reserve these into the old memory bank. Feel free to hit pause and then rejoin the video when you're ready to continue. This first problem you actually already know how to do. Integrate the sine of 3x dx. You can do this without substitution. I'm going to show you how to do it with substitution, and then I'll talk about how to do it without substitution, and maybe you'll see that it's a little bit faster approach. To do this, I'm going to let u equal the sine of 3x. By doing this, I can take the derivative of u, which would be 1 du, and the derivative of 3x, 3 dx. Notice I'm using the du and dx notation from implicit differentiation. You can solve this expression for dx by dividing by 3. Dividing by 3 is the same thing as multiplying by a third, so 1/3 du is equal to dx. And now I'm going to substitute. I'm going to get rid of the 3x with the u. Instead of sine 3x, sine u, since u equals 3x. Then I'm going to swap out the dx for 1/3 du. So I'm substituting two things here. Now I'm going to go ahead and integrate 1/3 sine of u with respect to u. If you want, you can pull the 1/3 out in front. The integral of sine u is negative cosine u. And the last step, I'll back substitute. Since I know that u equals 3x, I'll swap out the u with the 3x. So I get my final answer, negative 1/3 cosine 3x plus c. Now previously we could have just done this in our heads. The integral of sine gives me the negative cosine of 3x, since it's not just sine x. And then when I integrate, instead of multiplying by the derivative of the chain, this time I divide by the derivative of the chain. The derivative of 3x is 3, and I divide by 3 or multiply by a third. So my final answer with substitution. Just to give you an idea of how substitution is going to make this process a little bit easier. But let's do one that's a little bit more involved. So question 2 here has got a lot more going on. You can't keep track of all those things inside of your head, and you can't just simply divide by chains inside of your head. So I'm doing a substitution. The key here is to look for two functions. I have a 3x squared and an x cubed plus 5. The reason why I'm looking at those two functions is because the derivative of x cubed is 3x squared. That's my key when I want to use substitution, when one function is the derivative of the other. So now I'm going to assign u as my x to the third plus 5. I have to pick one of those two functions. And the reason why I want to let u equal x to the third plus 5 is because the derivative of u, 1 du, equals 3x squared dx. Now I'm going to rewrite the expression in terms of u. Instead of x to the third plus 5 raised to the 9, I'm going to let that equal u, and it's going to be u to the 9th. Instead of 3x squared and the dx, I'm going to substitute those out with du. And then I'm just going to simply integrate u to the 9th du. And then the integral, u to the 10th, divide by 10. I added 1 to the exponent, and then I divided. And then lastly, I'm going to back substitute. I know what u equals, and I'm going to swap it out for x to the third plus 5. And I get my final answer, x to the third plus 5 raised to the 10th, divided by 10 plus c. Here's a third question. Again, I'm looking for one function to be the derivative of the other. X squared plus 1. The derivative of x squared plus 1 is 2x. That tells me what I want to let u equal. In this case, I want to let u equal the green, x squared plus 1. The derivative of u is then du, or 1 du, equals 2x dx. Now my substitution. I swap out the x squared plus 1 with u, and instead of taking the square root of that, I raise it to the 1/2. And then I'm going to swap out the 2x dx with du. Integrating this expression in gray isn't that challenging. Add 1 to the exponent, and then divide by that new exponent. Don't forget your plus c. And now it's time to back substitute. If I know what u equals, I'm going to swap out with x squared plus 1. And you get your final answer in pink. The substitution helps you keep track of all of the different functions that you're taking the integral of. It's much easier to take the integral of u to the 1/2 than everything you see at the top in black. This next problem seems pretty easy. Integrate tan x. The only problem, that's not one of the flashcards. As you can see here, you have the integral of cosine, the integral of sine, but you don't have the integral of tan. That's because the integral shortcut is much more involved. So I'm going to have to use substitution to take control of that. I don't have two functions here. I have one function, tan x. And the derivative of tan is not written on the screen. So before I do my substitution, I'm actually going to want to rewrite this one. Tan can be rewritten as sine x over cosine x. This gives me my two functions. And now you can see that the derivative of one function is the other function on the screen. What I mean by that is that the derivative of cosine is sine. So that tells me to let u equal cosine x. Take the derivative of u, du, and I get negative sine x. Okay, the numerator only has the positive sine x. When I took the derivative, I got a negative. Well, there's going to be an easy way to take care of that as well. Let me show you. Let me rewrite the expression in terms of u. So the cosine is getting swapped out with u. The sine and dx is getting swapped out with du. And notice there's a negative, so I have to add a negative in as well. And now let's perform our integration. The negative will be placed out front. Everyone should know that the integral of 1 over u is simply ln. Keep the negative out front, so that makes it negative ln. Absolute value of u plus c. Do your back substitution for u, where I swap it out with cosine x. And I'll get my final answer, negative ln, absolute value, cosine x plus c. So if you want, you could remember the integral of tan x as this at the bottom. That one's kind of hard to remember for me, so I just always turn it into sine over cosine and just work it out. But that very well could be a flashcard if you wanted to. Here's the last problem that we're going to do. We're looking for two functions. I've got them, x and 2x plus 1. If you notice, one function is the derivative of the other, or pretty darn close to it. The derivative of 2x plus 1 is 2. But I have an x there, not a 2. Okay, so we're going to have to do a little bit more work on this one. I'm still going to let u equal 2x plus 1, and the derivative du is going to equal 2x. I can divide by 2 on both sides to solve for dx, getting dx equal to 1/2 du. And now let's do some substitution. The 2x plus 1 is what I let u equal, so I swapped out a u. The dx got swapped out with 1/2 du. My 1/2, my du. I'm going to go ahead and put the 1/2 out in front. Now, here's where I hit a bit of a problem. I have an x and a u, and I'm integrating with respect to u. So I cannot have that x there. I need everything to be in terms of u. For this one, I'm going to do a secondary substitution. I'm still letting u equal 2x plus 1, and I can solve that expression for x. Subtract 1 and then divide by 2. So now I'm going to swap out my x with u minus 1 over 2. This divide by 2 underneath the u minus 1 is really multiplying by half. So I'm going to pull that 1/2 out in front. I'm going to get rid of this 1/2 here. I'm going to multiply by another half out front, which makes all of that 1/4. This square root here bothers me, so I'm going to get rid of the square root sign, and I'm going to make that u to the 1/2 times that u minus 1. I'm going to now multiply u to the 1/2 times u, and then u to the 1/2 times negative 1. U to the 1/2 times u to the 2/2 is u to the 3/2. U to the 1/2 times negative 1 is negative u to the 1/2. Then I'm going to go ahead and integrate both of these u's. So after I integrate, u to the 3/2, add 2/2 makes it 5/2. Divide by 5/2 is the same as multiply by 2/5. Minus u to the 1/2 in blue, integrate, add 2/2 make it 3/2. Divide by 3/2 is the same as multiply by 2/3. My plus c and my 1/4 comes down. And then my last step here is to get rid of these u values for what u equals 2x plus 1. So my u, 2x plus 1, my u, 2x plus 1, gives me my final answer. If you wanted, you could distribute this 1/4. I don't think it's necessary. That pretty much wraps it up for integration with substitution. The key thing is to look for one function being the derivative of the other. Generally speaking, that's the function with more stuff going on, and that's what I'm going to let u equal. See ya!